Guys, today we're going to learn a new way to solve systems. We've already done graphing and substitution. Today we're going to learn elimination. A few reminders and announcements before we begin. If you have questions, make sure you email me right away. I'm here to help. It's definitely not too late to turn in late work for quarter 3 or quarter 4, but all of that does have to be done by the end of the month. You do not have until June to get that done. May 29th will be the last day I accept anything. Make sure you have out a pencil and paper. If you don't have that now, pause the video and go get that ready to go. You need to be taking notes and trying the problems as we go. Make sure you're using your school email address. If you haven't logged into your school email, then you won't be able to access the IP. There's never a reason to guess, leave blanks, or write IDK in an answer blank. You want to email me or attend office hours to get your questions answered, especially since you can still do all the late work. There's no reason to hit IDK and then hit submit. Ask for help. Don't forget that quarter 4 is going to end May 21st. If you're passing with a C or better by then and you're happy with your grade, then you're done. If you're not, you're going to need to continue working for 2 more weeks. So let's get these assignments handed in. Point project for the month of May. The project will be worth 10 points and will involve you choosing from a list of specific skills and creating a presentation of your choice on that skill. 10 points is equivalent to 1 missing e-learning assignment, so it could have a big impact on your grade. We've designed this project to be possible for every student to do and should be a boost to your grade if you make an effort to meet the requirements. The project will be due by midnight, and sorry about this, I made a typo in the PowerPoint. That should read Friday, May 29th. So May 29th is the last day for the project. The expectations and rubric for the project can be found on the Haiku page. There will be a second project available later in the month for an additional 10 bonus points. All right, our lesson today on email etiquette. Things we've covered so far. You need to be using your Riverside email. All your teachers have personal emails as well, but we use our professional emails for school business, as should you. Subject of an email should be a few words at most. The body of the email is for your message in complete sentences. All emails should include a polite greeting and closing. Requests should never include the saying ASAP. It's impolite. It's not too late to send Mrs. McNeely an email for bonus points that includes all the above, or copy me on an email to one of your other teachers. Here's an example of an email that I wrote to Miss Dorsey. Notice that I have addressed it to her. It's from my school email address. I have a quick subject line so that she knows exactly what it's about. The subject has complete sentences. It starts with a polite greeting. It has a polite closing. I don't expect that she's just going to do what I ask. I thank her for considering it, and I tell her exactly what I need her to do if she is willing to do it. So don't forget bonus points for sending me an email with all of these things covered. Struggles or celebrations this week. A few weeks ago, my brother and his wife had a new baby boy. They have one son named Gunnar, and the new baby is named Mac. I'm really looking forward to the time when I can visit them. All right, let's do some review. Remember that we have been working on how do we solve a system of equations. So my goal is to figure out what x and y are equal to. These represent some numbers. But I don't have enough information to solve one equation that has 2 variables. If I add in an additional equation with the same variables, notice both of these have x's and y's. If they don't have x's and y's, this doesn't work. And I already know that y is equal to 2x plus 3, then I can replace y in the other equation. So the other equation is going to stay exactly the same, but I'm going to replace y with a different thing that I know y is equal to. Y is equal to 2x plus 3. This looks more complicated, but the advantage of doing this is that I now have 2 x's instead of an x and a y, which makes this much easier to solve. So now I can distribute 3 times 2x is 6x, 3 times 3 is 9. I bring down the equal 17. 2x plus 6x is 8x, 8x plus 9 equals 17, minus 9 from each side, so 8x equals 8. Divide both sides by 8, and x equals 1. Now we're going to figure out what y is equal to. I already know that now x is 1. So I'm going to choose either one of these equations, and I'm a lazy mathematician, so I'm going to choose the one that's easiest to use that will give me the correct answer. So I'm going to use the top one because y is already isolated. I'm going to replace x with 1. When something is right next to something in parentheses, that means multiply. 2 times 1 is 2, and 2 plus 3 is 5. So I know the y value is 5. Our answer should always be a coordinate pair there. If you don't have this example down, you're going to want to pause the video and write this down now so that you have it to refer to later. These are a little different because both variables are isolated. We know that x is equal to 4y plus 5. The procedures don't change, just looks like it's a little different. I am replacing x with 4y plus 5. So this becomes 4y plus 5 equal to 6y minus 15. I notice some of us are having trouble solving when we have variables on both sides. You want to remember that if something is on opposite sides, we have to do the opposite. So this is a positive 4y. To get it over with the other y, I'm going to subtract 4y from each side. So I get 5 equals 2y minus 15. I'm going to add 15 to each side. 15 plus 5 is 20. Divide both sides by 2 to isolate y, and so y is 10. So remember, my answer should be a coordinate pair. I now know that y is 10. I need to know what x is equal to. Remember, it doesn't matter which one of these you use, so I'm going to use the top one. X is equal to 4 times y plus 5. Well, I now know that y is 10, so I don't have to use a variable for y. I know what it is. 4 times 10 is 40, and 40 plus 5 is 45. So x is 45 there. If you don't have this down, I want you to pause the video and write these steps down on your paper so that you have it to refer to later. All right, slope-intercept form looks like this y equals mx plus b. M represents the slope, b represents the y-intercept. When we solve a word problem, what are the key words we look for to identify the slope and the y-intercept? Well, to identify the slope, you're looking for words like per, each, and every. Something that's happening over and over and over. So $5 for each cookie box sold, $3 per magazine sold, 5 miles per day, 20 miles every week, those kinds of things. For a y-intercept, you are looking for some sort of a one-time fee, a flat rate, something that's happening one time. Okay, like the installation costs on your cable. You don't pay that every month. You pay that one time for the guy to come to your house and install your cable. I probably should have put on slope. Slope can also be a rate here. If you don't have all this stuff down, I want you to pause the video now and write down those keywords there. You will need it for your IP. All right, linear systems can be solved using graphing, substitution, or elimination. When solving systems, the equations must have the same variables. So you can't have an a and a b in one equation and an x and a y. So if we're going to do elimination, we want to use standard form. That's going to get all of our variables lined up. X's with x's, y's with y's, constants with constants, equal signs with equal signs. Unlike in substitution, where you want one of the variables isolated, we like to use standard form for elimination. The key to elimination is to get opposite coefficients. So let's talk about some examples of that. For example, -4 and 4 are opposite coefficients. If those were on an x, something like -5x and +5x are opposite coefficients. We can use multiplication to make opposite coefficients if necessary. Our answer will still be an ordered pair. All right, so let's go through one together. As a reminder, the equation must be organized in standard form, have the same variables, and we are looking for opposite coefficients. So you want to first start by noticing, do we have a system? Yes, we have two equations. Do we have these in standard form? A number with an x, a number with a y, equal to a number by itself. We don't have to worry about whether a is negative or not. We aren't being asked to write these in standard form. We're asking to solve the system, so I don't worry about that piece. We're going to multiply to get opposite coefficients if necessary. So here's what I want us to look at. I want us to look at our variables. Our variables are 2x and -2x, and -3y and 5y. Well, these are opposite signs, but not the same numbers. So those are not opposite coefficients. These are opposite signs and the same numbers. I want you to think about what happens when I add 2 and -2. Well, if you have $2 and I take away $2, you have $0 left. Those are going to eliminate, which is what we're looking for. So it's not necessary to multiply on this one because we already have opposite coefficients. Now we're ready to add our like terms. Because I put this in standard form, I can add straight down the columns. 2x plus -2x, that cancels out. -3y plus +5y is 2y, and 6 plus -10 is -4. What that has done is it eliminated, which is why this is called, sorry, this should say elimination up here. That's why this is called, because we are eliminating one of the variables. Now we can just divide both sides by 2, and so y equals -2. Substitute back into the other equation. We have 2x minus 3y equals 6. I am replacing y with -2, and now I am solving. -3 times -2 is +6. Now this is just a two-step equation. Subtract 6 from both sides, so 2x equals 0. Divide both by 2, and so x equals 0. So remember, my solution is always an ordered pair, 0, -2. If you don't have this problem written down with these steps, I want you to pause the video and write that down now. Again, this should say solving by elimination. Sorry about that. All right, so I want to take a look at this. Remember, we're looking at our matching variables. So these are already in standard form. We've got an x, a y, and a constant. An x, a y, and a constant. So now we've got 3x and 6x. These are not opposite coefficients. They're definitely not opposite signs, and the numbers aren't the same. We've got -4y and +4y. There we go. That's our winner. That's what's going to eliminate when I add. So we're going to add straight down the columns. 3x plus 6x is 9x. -4y and +4y eliminate. We don't write y because that would mean 1y. 17 minus 8 is 9. Now we're going to divide both sides by 9, and so x equals 1. We're not done because at the end, my solution is supposed to be an ordered pair, 1 comma something. So I'm going to replace x with 1. We could have used either equation. I just used the top one. 3 times 1 is 3. Notice that now I need to solve my equation. I'm going to subtract 3 from both sides. So I get -4y equals 14. Divide both sides by -4s cancel out. I'm left with -14 over -4, but let's clean that up. A negative divided by a negative becomes a positive, and both of these numbers are divisible by 2, so that answer can become 7/2. So it's 1 comma 7/2. It's perfectly okay to have a fraction in your answer here. All right, I want you to pause the video. I want you to notice that -4x and +4x are already opposite coefficients, so you are ready to add straight down the columns. Go ahead and do that now. Welcome back. You should have noticed that when you add -4x and +4x, they cancel out. 3 plus 9y is 12y, and this becomes 21 plus 27, which is 48. We divide both sides by 12, and so y equals 4. I'm going to replace, in either one of these equations, I'm going to replace y with 4. So that becomes -4x plus 3 times what would have been y, but now y is 4. So -4x plus 12 equals 21. Subtract 12 from each side. So -4x equals 9. Divide both sides by -4. The negatives don't cancel out, and -9 over 4 cannot be reduced, so we just leave that. So my answer is -9/4, comma 4. All right, last two we're going to do today. We're going to solve using elimination, but I want you to notice now that these are not opposite signs. I'm actually going to pause the video here and do another one, and so you're going to head back to Haiku and go ahead and go on to part 2.